Maybe we'll wait a couple minutes so that people join. All right, let's start. Ben, welcome to DevOps Underground. Thank you for coming to talk to us today. Could you please tell us a little bit about yourself?
Sure, yes. My name is Ben Ellaby. I'm the VP of Engineering at a company called Theodo, so based in London, and I help other people build digital products, primarily using serverless and heading up our teams building with serverless. So yeah, developing a lot with cloud-native technologies in AWS.
Sounds exciting. Can you tell us a little bit about your talk today?
Yes, so today in the talk, we're going to go through the best practices for keeping your Lambdas secure. So Lambdas are the function as a service from AWS that allow us to run code in a serverless way. So we're going to talk through sort of the 10 sort of checklist items of how we can keep those secure when running in production.
Sounds amazing. Take it away. The stage is yours.
Awesome. Thank you so much. Well, hi, everyone. I hope you can see my slides and just drop a message in the comments if you can't. But yes, my name is Ben, and today I want to talk to you about how to not be SecureLess. So the best practices for keeping our Lambda secure. As I just went over, I'm Ben. I'm the VP of Engineering at a company called Theodo. We help other people build digital products. And I'm also an AWS serverless hero, meaning I get to speak at meetups like this, speak at conferences, and work with AWS on improving some of their products and some of their services. I write a lot about serverless on the Serverless Transformation blog, and you can follow the content I produce on Twitter at @LaBBen. And if you want to hear more about Theodo or the open source projects that we have, you can go to theodo.co.uk/experts/serverless. Now, before we jump into Lambda and the security aspects of that, it's probably good to get on the same page about what serverless means. Although a lot of you have probably heard of it and are familiar with it, it's one of those terms that means different things to different people. At its heart, it's an architectural movement. It allows developers to send application code which is run in a completely abstracted and isolated way from that developer. So they write some application code, send it to the cloud provider, and then it's run triggered by a big range of different events. With serverless architectures, we also try and leverage more and more third-party services to manage things like backend logic and states. things like Cognito for identity management in AWS, or Okta outside of AWS with a similar sort of role that it fulfills. And really, serverless services cost us nothing when we're not using them. So it's a real pay-per-use pricing model. There's also a framework with the same name, an open source framework called the Serverless Framework. Really useful, but does make it confusing when talking about serverless. Some of the examples we'll look at later on do make use of the serverless framework, but really we're going to be focusing on serverless, the architectural movements. Now, why do people take a serverless approach to building applications? Well, first of all, there's a cost reduction. First of all, the AWS build can actually be reduced depending on your traffic patterns and how you build your application. On top of that, there's a reduction in the total cost of ownership. As we've abstracted away the underlying details of the server that's being used, we don't have to think about security patching. We don't have to think about the operational management of that. And therefore, there's a reduced cost of building, but also running and maintaining those applications. There's not no ops, there's really different ops. We can focus our operational resources on more value-bringing stuff, things like how we can have blue-green deployments and how we can A/B test in production and do FinOps and more optimization of our architectures. Developers can focus more on delivering business value as they're writing the code that is the bespoke business logic of that company, instead of writing the sort of generic infrastructure or even those components that can be replaced by third-party services as we spoke about before. These services are also scalable from day one and scale to a very great degree. And as we start to make more efficient usage of the service in our data centers, we'll also hopefully start to reduce the carbon footprint of the internet, which is currently growing rapidly and is now bigger than the aviation industry. Now, it's not just Lambda. This talk will focus on Lambda, but it's important to remember that serverless architectures have a sort of wider set of services than just simply Lambda. Now, Lambda is the functions as a service from AWS, that compute service that allows us to give a piece of application code and have it be run in a completely serverless way. But serverless architectures also make use of S3 for storage. DynamoDB is a completely serverless NoSQL database, API gateway to route events into to route HTTP requests into our serverless architecture to trigger something like a Lambda function or other services. Cognito for authentication, so identity as a service in a completely serverless way, SQS for queuing, and event bridges for building event-driven architectures and routing those events through our application. Combining these together gives us a great amount of power and flexibility, and we can build really interesting architectures. And if you're interested in that, on the Service Transformation blog, I've written an article on Xavier Lefebvre, one of my colleagues, has written an article on what a typical serverless architecture looks like, and you can look through that and see how these can be composed in different patterns. But today we're really focusing on Lambda, that computes functions as a service from AWS. And although the patterns and sort of the best practices we're going to look at are particular to AWS, these same patterns and best practices would apply to other functions as a service services from other cloud providers. Now, with Lambda, one of the key things to think about is the temp directory. And we're going to go through a checklist of different things we should be doing to ensure the security of our Lambda functions. Now, on a Lambda function, the temp directory is the only place you can write to disk. This can be really useful for performance optimizations. For instance, if we have a Lambda function generating a PDF using something like a headless Chrome, writing the PDF, generating it to disk, and then uploading it to something like S3, it can be really useful to be able to have that persisted or to make use of that sort of on subsequent calls. But it reduces a sort of sandbox isolation that's actually quite useful from Lambda. With a Lambda function, the first time it's called, we spin up sort of that container actually under the hood, or that micro VM. And then if it's called subsequently, we get what's called a warm invocation. So the first time we get the cold start time, when the host has to sort of get into sort of the cache of containers. But then after that, subsequent calls will be a warm invocation. But on those warm invocations, that temp directory actually still has the same content that it had from that first invocation. So we can actually start to leak information between those Lambda function invocations. If we're generating a very sensitive PDF and maybe we don't have good naming conventions, a slight error in our application code could actually lead to us sending sensitive information that's been generated in a PDF on a previous call to the wrong user, which would obviously not be a good result. EFS, which is the Elastic File System, has changed this slightly as it's another way we can interact with disk, but for most users of Lambda, temp directory is the main concern. So we always want to remove any file we've written to the temp directory unless we're explicitly doing it to optimize performance and have considered the possible security risks. One sort of brute force way of doing this, which we sometimes do in our projects, is to basically just recursively remove the temp directory after each request is finished. And you can use a framework like MIDI, which is a middleware framework that's very useful for Lambda, to be able to sort of automate this in your code and not have to think about this concern too much. Now, do be careful not to run this on the wrong directory, and especially not to run it on the wrong directory on your local computer, as that would make you not very happy as the end result. This is a sort of brute force tactic, but overall, just make sure if you're writing something you remove it. And you can be clever, you can write your own sort of SDK around writing to that disk, and you can make sure it cleans just that file up, or you can do something more brute force like this. The next point to come on to is more architectural, how we sort of separate our Lambda functions. And it's quite a big topic. In AWS, IAM is sort of how we give security access to things, and it's really useful, and roles are how we allow a Lambda function to be able to have access to different resources. For instance, a Lambda function might need access to S3 or to credentials stored in something like parameter stores, secrets manager, and IAM roles are how we do that. But from an architectural point of view, we can build in many different ways. We can have one big Lambda function that rules them all and sort of runs almost routing and just gets all the requests and does what it does with them. Or we can break down into very small sort of micro Lambdas that do one thing and do it well. And this allows us to have more fine-grained access control. If we contrast two ways of building the same architecture, on the right, we have one monolithic, one Lambda to rule them all. And on the left, we have many sort of micro Lambdas doing individual tasks. From an application coding point of view, we're writing code, it's being shipped, it's being run. What's the impact? Well, there's a performance impact to having extremely large package sizes. There's, a coupling impact of building all that together. But also, let's say we do have a very sensitive API key, something for Stripe that we're storing secrets manager or parameter store as an encrypted string. We don't want to give all requests access to that. We only want to give those requests that need access. If we have a generate invoice function that calls that, the one I just highlighted in red, we can give that one Lambda function access to that secure credential. We can have different authentication on that Lambda function, and we can even put it behind a different mechanism for triggering that might not even be public internet. But if we have that monolithic one Lambda to rule them all, and that's doing invoicing, but it's also doing getting orders and making quotes, well, we're going to have to give that IAM privilege to the whole of that Lambda function. So for all the source code that's there and all requests that get routed to that. The lesson here is to really keep our Lambda functions fine-grained with a clear separation of concerns, using specific roles and specific policies for each, not using one role across all the broken down Lambda functions and not just using one Lambda function to do everything. A point on this, just to make sure, of course, educating developers around how to do this, but also making sure we put checks in there so mistakes aren't made. And if mistakes are made, we can quickly rectify them. Automating checks is a really great way to make sure that you're always building within these safeguards, and with infrastructure as code, it's becoming easier and easier to put these checks in place. There are things like CloudFormation Guard, the serverless framework has something called safeguards, and actually an open source tool that we built at Theodo called SecureLess Dev Tools, which is sort of a dashboard where you can interact with different serverless resources, has a tool called Guardian, which is a CI tool, which goes over your architecture and checks several best practices. And here we can see a best practice has failed on the following function resources, and that's because they're all sharing the same IAM role. We're sharing the same set of permissions across all those Lambda functions, which is unlikely to be the best practice, as we're probably sharing more things to some of them that they don't need. And instead, we need a one role per function setup. Moving on from there and sort of taking the same lessons from IAM and seeing how we can break it down even further. IAM is a great tool to secure applications, and developers have been massively empowered by serverless. We've abstracted away a lot of stuff so we can build very quickly and move very quickly. But if we don't fully understand IAM, this can actually be quite dangerous. If we use policies in the wrong way and give too much access, this can be a big security vulnerability. One useful tool is called AWS Least Privilege, and this will automatically look at your CloudWatch trails and then retrospectively tell you if your IAM policies are correctly configured or not, and tell you what the few things that those things are accessing, what they should access. And this is obviously retrospective. It's better to design them well from the start. But the key message here is to ensure all of our IAM policies allow the least privileges needed to perform their task, and train our teams as well as enforcing these on the CI. You don't want to see stars in the resources of your IAM policy, but you need to train your teams to know why that's important, as well as automating checks to make sure they don't get into production. If we move back to a sort of application architecture and how we route requests into our application, typically with serverless architectures and Lambda, we put a API gateway in front of them. And this allows us to have HTTP routes coming in. Now, if we have super secure, very private Lambda functions that are doing very internal jobs, they don't necessarily need to be on the public internet. We can hook them through the AWS SDK from a secure environment, and therefore not everything needs to be on the public internet. When we do want things on the public internet, we want to well configure our API gateway. Now, API gateway can provide some denial of service and rate limiting, and we can add a WAF, a web application firewall in front of that to add more protection. And of course, we want to do authentication. We want to do authentication inside of API gateway. When a request comes in, we want to validate that JWT inside of API gateway before it gets a chance to run our Lambda code. A lot of people put that verification inside of the Lambda code, but really if we do this at the API gateway level, there's no chance of sort of code injection into that Lambda function. It's completely separated. As I mentioned before, a web application firewall is our sort of first line of defense against web exploits. It looks for things like cross-site scripting, SQL injection, and many other things. And it can also do denial of service and set particular access control around geographic regions and other things like that. It integrates really well into API Gateway. There are some things to look out for. Yang Kui, another AWS serverless hero, has written a very good article on the API Gateway security risks you're not paying attention to. So feel free to read through that and get sort of a deeper dive on it. But the key thing for us is to avoid exposing our Lambda functions to the internet if we don't need to. And if we do expose them, we only want to invoke them through an API gateway with a well-configured WAF and make sure that authentication or the authorization is happening inside of API gateway, not the Lambda function. Once we have something in production, we obviously need to know what's going on to know there's a problem and spot it early. Now, CloudWatch and X-Ray are great tools inside of AWS. And as we build serverless architectures, they actually get more and more difficult to debug because we might have a request comes in through API Gateway, triggers a Lambda function, triggers a step function, which then triggers another Lambda function, which goes to SNS, another Lambda function, and then triggers an event bridge rule, which finally writes something to S3. That's a complicated path to trace across. So though CloudWatch and X-Ray are very useful, you can get insights from Lambda insights inside of CloudWatch on CPU, duration, and spot outliers there. You typically want to make use of a dedicated third-party tool that works off these, but also adds functionality. So Thundra, Epsagon, Lumigo, Dashbird, Datadog, these are all great tools for us to be able to interact with distributed observability and are specifically designed for serverless, which is the important part because serverless architectures are quite different and they require particular observability tools to work well. The key lesson here is that obviously basic logging is a given and we can add CloudWatch and X-Ray logging, and a dedicated third-party service can be really useful. One side note, and it's not necessarily on security, but we should build these logs to be recoverable. If we have that request flow that I mentioned before with many different services and then one final destination, if something breaks partway down that process, some of those processes run, some of them haven't, the log that comes in that broken step, we want to make sure that we can recover from that, we can re-trigger it and have the right information to be able to recover from that error later on. So with the logging in service applications, really important for observability, really important for security, but also important for recoverability when things do go wrong. Next, moving away from not necessarily serverless security aspects, but general security aspects, serverless has changed many things about how we build applications. We no longer think about patching the operating system, but we do have to think about writing secure code, access control, dependencies, encryption, and that's why the OOPS top 10 are still super relevant. If you're not familiar with the OOPS top 10, definitely give them a read and make sure your team give them a read. And there's even a serverless OOPS top 10, which I definitely check out. It's still quite in the early phases, but it's worth looking through as there particular web application security concerns that we should be paying attention to when building a serverless architecture. The key lesson here is to keep applying best principles when building your web applications. And if you're using serverless, do all the things we mentioned before, but also look at the OOPS top 10 and make sure we're still paying attention to cross-site scripting, we're still paying attention to SQL, and use dedicated tools like SNCC, which is really great for dependency auditing to make sure we don't install dependencies that are insecure, and Protego, which is a dedicated serverless third party, but automated tools can really make our life easier in this space. Next, in terms of sort of the developer flow and how we build and run our applications, is account security. It's great to have one AWS account per environment. We don't want all of our developers necessarily having access to production and having the same level of access that they have on development as they do in production, but we also want developers to be empowered with the AWS console and to be able to experiment with new services before necessarily they're approved or supported in our architecture. We can all one account per service strategy, which is becoming more and more common, and we're starting to do more and more of our projects, where maybe we have the payroll system and maybe we have the product system, and they're two separate microservices that don't actually interact, completely different bounded contexts. We'll actually put them in their own dedicated AWS accounts, again, split by environment. So we have 2 and 3 environments, that becomes 6 AWS accounts, all managed through AWS organizations, which aggregates the billing and policies, really useful. You don't want the CFO of your company to then get 30 invoices from AWS. We can aggregate that all together. We can also aggregate some IAM policies, which is really useful. But an account per service strategy really helps us to reduce the blast radius of any potential problem that might happen on AWS accounts, and also reduces some of the load of a developer trying to look through multiple microservices at the same time, and allows us to only give people access to things they should have access to. And MFA is never optional. MFA to access your AWS accounts, of course, never optional. MFA also to use the CLI and use those access keys that many people put in the AWS credentials file. Use MFA on the command line. It's quite easy to do. You can write a short script to do it. Or AWS SSO can be a great help here. And look up AWS SSO, which enables us to use our dedicated single sign-on for organization to authenticate not only our connections to the AWS console, but also when we're running from the command line. The key message here is to secure your development, test, and production environments and separate them to mitigate human error and attacks. And MFA is never optional for your teams, of course, for AWS, for command line AWS, and also for email and everything else. MFA is a key tool to help protect you. In conclusion, serverless does take away some concerns, like patching, operating system updates, monitoring disk, but there are new attack vectors and mitigating them is key. Developer speed and autonomy is great, but it can threaten our security if we don't think about it in the right way. So operational teams need to make sure that they're coaching developers to be empowered by this new technology and automating best practices to safeguard against any potential problems. There's also an article going through this checklist that I released on the serverless transformation blog. So feel free to go to that. That's serverless-transformation. You can find it on Medium quite easily. And the auditing tool that we saw earlier is part of SLS DevTools, which is an open source project that we run at Theodo. It allows you to interact with your serverless architecture, so you can see your logs, your invocations, invoke functions, look at event bridges, switch regions. But also, if you run it with the --CI flag, instead of opening this sort of GUI in your terminal, it will run a set of automated checks, and you can turn those off on a per rule basis. And it's really easy to add your own rules as well. So as an organization, as you develop your own best practices, you can add those in there. And there are other tools that do a very similar thing. Lumigo have Stethoscope, or Stacoscope as it's called, which does some safeguard checks. The serverless framework, the company behind that, Serverless Inc., have a pro version where you can have safeguards automated there. And there's CloudFormation Guard and many other tools, but make sure you're automating some of these best practice checks. If you want to find the slides for this, you can go to slides.com/Ben Ellaby. If you want to find that open source project or the other open source projects that we do, or want to reach out to us to talk about your serverless architecture, then you can find us at theodo.co.uk/experts/serverless. And I realize we've gone through that quite quickly. So if there's any questions, if you ask them in the comment section, we can go into a sort of Q&A session here.
Thank you, Ben. That was excellent. I agree with everything, especially about MFA not being optional.
Thanks.
All right. Not seeing any questions at the moment. Please feel free to post them at the meetup as well, and I'm sure we'll pass them over to Ben.
Yeah, definitely.
There is something else. Thank you. There is something else I wanted to present to you today. 1 second. There we go. Our sponsor, JFrog, is hosting a free hands-on technical workshop. You'll get to experience and work with JFrog platform outside the DevOps expert. We'll give you guidance on configuring and using the free platform to establish best practices for successful DevOps on how to collaborate, build, and deploy apps fast and secure. And I'll put a link to that on our DevOps Underground meetup as well. All right. Thank you very much for your time. And we'll see you next month.